Hi, we are a slice of Raspberry Pi. I'm this project's leader, Woody Montalis, and I was in charge of compiling the report and working with the team on the parallel programming aspect of the project.
Hi, I'm Aaron Portal. I helped out with Task 3, the parallel programming. I helped out with coding with the Raspberry Pi and all the stuff that entails, as well as Task 4. I helped out with that programming as well with the arithmetic files and all that. So,
Hi, I'm Matthew Trella. I helped in the parallel programming part and I helped in creating the video.
Hi, my name is Lee Ben. I'm working on the question coming from introduction of the parallel programming, and I also joined to the ARM assembly.
All right, awesome. So, this project was geared a lot more towards how we use the parallel programming system as well as more serious applications of ARM. So, what do you think you guys have learned from this assignment?
Yeah, so from this assignment, it tells us basically what's the parallel computer. So the parallel computer has three different types. It's either a single instruction can handle the multiple dates, or with multiple dates working either on a single date. No, sorry, my bad. Or it's either a multiple instruction working on a single date or a single kind of date or different kind of date on the same time. That's three kind of the parallel computer. Then for the parallel computer, we have so many models. Two of the most important part is the shared memory, that's the basic. And then on top of that, we have the shared memory with the threads. Use this one, we can work on more specific tasks, but also it will cause the code will be more complicated. So we need to pay attention when we do the coding. Then for the system part, we have two different systems. First is our normal computer. We will see the CPU, GPU, every processor separate, or our Raspberry Pi, the ARM assembly, everything on one chip. It will make the size smaller. It can also work on so many types of work. So based on the different requirements, we can choose different systems. It will become more economic.
Right. So, based on all the things that we learned from those sections of the project, I think it's safe to say that how we can apply this is really powerful inside of our personal lives or our professional lives as programmers. Being able to use these systems and go into depth with parallel programming will make our programs not only more powerful, but more flexible and more capable for all the tasks that we have to do with the different computers that we work with. So beyond that, what do you think were the best, most challenging, and worst experiences from this project?
from the project, I'd say the worst experience was probably dealing with I believe it was Task 3, where we were dealing with the third program. It was what it was called. We had to deal with a assigned half word as it was declared in the data variables, and we were really confused as to why it wasn't working because it was a assigned half word, and we couldn't figure out exactly why it wasn't working. And we found out it was the data declaration. We had to switch it from how it was as literally writing S half word. We had to change that, and we made it into a half word, which simplified things and made a lot more sense. And second part in the program, the memory, when we were going through breakpoints and the GDB, the debugger, we had a lot of trouble just trying to understand the values of each number and how they corresponded. As far as we knew they were hex values, but we wouldn't understand why we were getting specific hex values within the memory. And that took a lot of work to completely understand that section of the project. So yeah, that was probably the hardest part of the project for us.
So the best thing about the programming part was initially when we started coding, we didn't really come across any errors and our code was working fine, but we didn't know exactly how the code was performing, what it was performing. So as we changed up the code, we did come across some errors, which helped us in getting to the problem and addressing it and solving the problem. So which I think is beneficial for us in this field.
And besides that, one big thing that we learned throughout the projects actually is just the perseverance to work through all of these problems that we have, being that we face so many bugs and errors that we at first don't understand, and it takes so much research and so many trials to get past one of these bugs. So it just taught us that perseverance is one of the most important things as a computer scientist. And that is Project 3 from A Slice of Raspberry Pi. Hope to see you guys again soon.
Yeah.
Peace.
Peace out.